Okay, so this is this was the thing we started in the last class. In the last class, FPGA. What is the full meaning of FPGA? Wait, full meaning of FPGA is field programmable gate array. Field programmable gate array. Here you can see it is a field programmable gate array. Is an integrated circuit designed to be configured by the consumer or customer or a designer after manufacturing, hence field programmable. That means you can buy the device. Field means not the field. Field means your field of work, where you work. You buy the thing and bring it to your field, and you can sit and make the programming, and you can use the device. So that's why this is called field programmable device or field programmable gate array. Gate array means there are lots of arrays filled with gates, universal gates. Okay, FPGA configuration. Now, few points you have to understand. Larger and larger logic circuits needs to be accommodated in a single chip. If this is your case, the FPGA is your thing to go. That means if you have a circuit that has lots of logic circuits, and you want to make it in a single chip, that time you have to use FPGA. One way to quantify the circuit size is to assume the circuits to be built using only simple logic gates, then estimate how many of these gates are needed. That means when you have a big logic circuit, how do you know which FPGA you need to buy? Anyone is having any problem? Okay. So how do you know which FPGA needs to buy? So the only way to assume that, wait 1 minute. A simple way of assuming is that you convert your whole logic circuit using NAND gates, right? Because we can convert any logic circuit using NAND gate or using NOR gate, because that's why they are called universal gate. We can replace all the gates by NAND gates or NOR gates. That time you count how many NAND gates you need. That is the number of your gates you needed. So you need to buy an FPGA that has more gates than that. Okay, who wants to say something? Oh, permission. Okay, of course I can give you the permission. Wait, where is Shojib?
Sir, I'm here.
Okay, I'm making you co-host so you can record the class. And where is Abdi? Where is Abdi Aziz? Yeah, he record the class as well. So I'm making you two co-hosts so you can record. Anyone wants to record, you can ask me as well. Okay, share screen again. Who is that? I will record, right? Okay, Mizanur. Okay, Mizanur, you can record as well. Okay, now see, so when you configure that, okay, this is the number of my NAND gates in my circuit, you buy an FPGA that has more NAND gates than that. Okay, and remember, by today's standard, A logic gates or logic circuit with 10,000 gates is not large. If your circuit has 10,000 gates, that is not a large circuit, that is a small circuit, remember. Next. What is happening? Okay. Now, FPGA is a programmable logic device that supports implementation of relatively large logic circuit. Not like CPLD, FPGA do not contains AND or plane. Like PLA, PLD, CPLD, FPGA do not contain AND or planes. FPGA do not have AND gate or OR gate. Instead, FPGA provides logic blocks for connecting the pins of the package and interconnection wires and switches. And normally it has universal gates, either NAND gate or NOR gate. Okay, and it has some blocks that connects your input to your output, and it has some intermediate interconnections, wires and switches, something like that. Okay, these logic blocks are arranged in two-dimensional array depicted as hollow black box. Remember, you do not have to memorize this thing. This will not come in your exam. This is for just information. Okay, you just read. And the interconnections wires depicted as a solid blue box are organized. Okay, you do not have to think. You do not have to read that. Programmable connections are also exist between input-output blocks and the interconnection wires. FPGA can implement circuit of more than 1 million equivalent gate in size. That means if your circuit has more than 1 million equivalent gates, you can use FPGA for that. If that is way more than that, that time you have to use CPU. That means the computer CPU, like Core i7, Core i3, Core i9, something like that. So that time you cannot use FPGA anymore. Okay, so let's see an FPGA. Here you can see a picture. In this picture, this black box, that is the FPGA. The Altera written is there, right? Altera Cyclone 2. This is the FPGA. Now, normally you can buy these as a chip and bring it and use it in your own own PCB or printed circuit board, or you can buy the whole board. This is called FPGA board, right? You can buy the whole board as a package. Now, why the boards are necessary? These boards are necessary for prototyping. That means for checking purpose, because all of the necessary things are connected. Like it has some switches, it has some LEDs, it has some 7-segment displays, LCD displays, some pins, SD card, some external clock are there, some USB ports are there. It has an Ethernet port, some Ethernet port, some VGA ports are there also as well. So this is a complete package. There you can take some input and give some output as you wish. This is a prototyping board or a development board. That means you can learn your programming skill there. It is not for final use. The final use will be you will have your own PCB or printed circuit board. There you will put your FPGA chip. That will be your final circuit. But this one is good for prototyping, like the Arduino. You have Arduino, right? Arduino is a big board. Now you can use the big board in your project as a prototype, or you can use only the chip. Here you can use only the chip and make your own printed circuit board, or you can use the whole board as well. Now that's the picture of FPGA. Let's see the configuration. Okay, this is the structure of FPGA. FPGA normally has lots of input output cell, IO cell. This blue box. Can you see the blue box? These blue box are actually your input output cell, IO cell. That means your input and output pins. And these are your logic cells. These are your blocks of universal gates like NAND gates and NOR gate. And in between them, they have some programmable interconnect. Programmable interconnect means if you want to connect these with these, you can make a connection. You can make a connection there. That is called programmable interconnection, right? Okay, this is the structure of basic structure of FPGA. Now, normally the FPGA is much more complicated than this, but this is the basic structure. Now, there is a comparison between CPLD and FPGA. Let's see. Capacity. there is obviously a capacity comparison. SPLD, like your PLD, PLA, PAL, those things have actually 0 to 200 gates, equivalent gates. 0 to 200 equivalent gates, and that will be called SPLD. If your number of gates is more than 200 and less than 12,000, that will be called CPLD. And if you're in case of FPGA, that is completely different. CPLD and FPGA, they are not same, they are different. You can see some CPLD way more powerful than some FPGA, right? It has 12,000, it has 1,000. So some CPLDs are powerful than FPGA, but FPGA can be way more powerful than CPLD. So FPGA equivalent gates will be 1,000 to 1 million. So that will be your FPGA equivalent gates or the capacity. Now see the application where the CPLD and FPGA are used. CPLD implement the random glue logic or replace the circuit previously implemented by multiple CPLD. That means, let's see, you have a big circuit that has multiple SPLD, like multiple PLA, 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 right? So you want to replace that and you want to change the circuit. You want to make it even simple. So that time you will use CPLD. Like you have 5 PLA. So you want to replace that or you want to change the circuit, then you will use 1 CPLD only. Or if you have a circuit that has multiple AND gates, OR gate, NAND gate, no, not NAND gate, AND gate, OR gate, something like that, simple logic, that time you can use CPLD. Number 2, circuits that can exploit wide range of AND gate or OR gate and do not need very large number of flip-flops are good candidate for implementing in CPLD. That means if your circuit have lots of AND gates, lots of OR gates, and do not need any flip-flops. Flip-flop means memory unit, right? Memory unit. If you do not need any memory unit, if you do not need any flip-flops, that circuit is a very good candidate for CPLD. Now, what is the application of FPGA? FPGA can be used in various applications like prototyping, FPGA-based computer, on-site hardware reconfiguration, DSP, that means digital signal processing, logic emulator, like your basic games. Like when we were a child, আমরা কিন্তু কিছু গেম খেলেছি. We played some games like Super Mario, like Contra, like some racing by using our TV. Okay, my internet connection is unstable. Can you hear me?
Yes, sir.
Okay. If you find any problem, unmute yourself and say, okay?
Okay, sir.
Okay, now the application of FPGA are that prototyping and okay, logic emulator. What is logic emulator? Logic emulator is actually the games or some software emulation. Like in our childhood, we actually played some games, right? Like Contra, like Super Mario, some classic games. Those games actually do not need big CPU like Core i3, Core i7, Core i5, or Ryzen 5, Ryzen 7. It do not need those sort of what is that? The big CPU. It do not need that amount of power. It needs something very simple like an FPGA. You can use an FPGA and make a games like that. Network component. Network components means like an ATM machine. Normally ATM machine have a what is that computer inside it, but you can make an ATM machine using FPGA, and you can make simple computers like your video monitoring, or like your broadcast monitoring, or you want to make one video channel, you want to cast some music, cast some movie, something like that. You do not need a very big computer. You can use a very small computer like FPGA computer, and you can do that as well. Now, next part of our this topic, okay, the memory. What is actually memory? Memory is not your ROM. Remember, memory is not your 1 terabyte hard disks, okay, or your 240 GB SSD. That is not your memory. Remember, that is not memory, that is storage. Memory is actually RAM. The RAM you have in your phone or in your computer, that is actually your memory. The memory is the best essential element of a computer because computer cannot perform simple tasks. The program and the data that the CPU requires during execution of a program that are stored in this memory. Computer memory is of two basic types. One is primary memory, another one is volatile memory. Remember, primary memory, another one is secondary memory. So primary memory is often called volatile memory. Volatile means bhule jay, je memory ta bhule jay. That is not the actual meaning. The volatile means the memory that lost its data when the power is off. That means the data is temporary. Secondary memory is non-volatile memory. Non-volatile means the data do not that means it do not lost its data. So again, memory is the best essential element of a computer because the computer cannot perform simple tasks. The program, the data need program and the data that the CPU requires during the execution of a program are stored in this memory. Okay, let me give you an example. I am going to give you two numbers, and you will add and give me back the result, the addition result. Okay, add 5 and 2. Add 5 and 2. What you will do? You will take 5 and 2 and you will perform an addition, right? 5 plus 2 is 7. Okay, then you will give me the 7, right? Now when I say 5 and 2, after 2 seconds or after 1 second, if you forget the 5 and 2, what will happen? If you do not have a memory, how can you memorize? You need to add 5 and 2, right? You will forget. I say something, add 5 and 2, you will forget immediately. I told you to add 5 and 2, right? Because you do not have a memory. If you do not have a memory, you will not memorize. I told you will not remember. I told you to add 5 and 2. Okay. After the addition, how do you know the result will be 7? How do you know what you have to do in addition? কিভাবে জানো? তুমি কিভাবে জানো যে add করলে কি হয়? Because your mom or your dad or your teacher or your brother told you in case of addition you have to do this, right? That is inside your memory. And after addition the result is 7, right? You need to keep it in your memory, otherwise before saying it to me you will forget. You add and make 7, right? Then you will speak, sir, the answer is 7. But how do you say that if you do not have a memory? You have a memory, you keep that 7 in your memory and you say the answer is 7. Remember, this memory is temporary. There is not a permanent memory because I am telling you to add 5 and 2. That is a temporary thing. After 2 days, you will forget this. You do not have to memorize it, right? You do not have to remember this. So add 10 and 12. The addition will be 22. You will forget this after 1 hour. If I tell you, okay, what was the number I told you to memorize, or I told you to add, you will forget because that is unnecessary information. After the result is published, that is unnecessary information, right? Obviously. Now see, so secondary memories are not non-volatile memory. Those are actually your ROM. Remember, those are actually your ROM, not storage. That is not your storage, that is your ROM. That means where your operating system will be. Operating system means what to do when you have to add. That is an instruction, right? That instruction needs to be stored somewhere. You will never forget. What to do if you get sick? What to do if you get hungry? This information should be stored somewhere safe and for rest of your life. That is called ROM. ROM, ROM, read-only memory. That do not forget. Remember. Okay. So let's get back. So to the classification, memories are classified into 2 types. One is primary, that is your that is your RAM, primary, and another one is secondary, that is your ROM. Normally the primary memories are very small, and the secondary memories are very big. The primary memory or the RAM can be divided into 2 types. One is SRAM, another one is DRAM. ROM can be divided into 3 types: PROM, EPROM, EEPROM. Okay, what is the full meaning of RAM? RAM, random access memory, read-only memory. What is the full meaning of PROM? PROM is programmable read-only memory. That means you can program it. That means you can give some data there, right? Now EPROM, what is the full meaning? erasable programmable read-only memory. What is erasable? Erasable means you can erase it. Next one is EEPROM. What is EEPROM? EEPROM is electronically or electrically erasable programmable read-only memory, right? Electrically erasable. Electrically erasable means the previous one. Then how can you erase the previous one? The previous one is very interesting. You have to erase the data using UV light, UV, ultraviolet light. For this one, you have to use normal programming. Just give erase or format, it will format. This one is different. Now, I will show you what do I mean by that. Okay, it is raining, it is raining. The full meaning of SRAM. SRAM is static RAM, that means static random access memory. DRAM is DRAM, that means dynamic random access memory. Remember this, because sometimes I give 2 marks, 3 marks questions from here. Okay, what is the full meaning of EEPROM? Something like that. Okay, ROM. Here, can you see some hole? Can you see some hole? Okay, this is an EP. Yeah, okay, this is an EPROM. EPROM means erasable programmable memory. Okay, erasable. That means when you have a data inside this chip, if you put some UV light here, UV light. If you put some UV light, the data will be gone. The data will be erased. That's why it is called erasable. Now, the modern device do not have a EPROM inside it. It actually prefers EEPROM. EEPROM. Okay, EEPROM, electronically or electrically erasable. And something PROM. PROM means you can never erase that. You can never erase that. Like your Android phone. Inside your Android phone, there is an operating system. You can update that. You can do whatever you want, but the data is given permanently. That is there. That is in PROM. Okay. Now, what is the purpose of ROM? It stores crucial information essential to operate the system, like the program essential to boot the computer, booting device. It is not volatile. That means it is not erasable. Okay, it is not volatile. That means it do not forget. It is erasable, but
Can't we rewrite the PROM?
Okay, you cannot rewrite the PROM. You cannot rewrite the PROM. You can rewrite the EPROM or EEPROM. Okay, that's why they are called EPROM or EEPROM.
But some Android phone we can customize the operating system. But how is that?
Okay.
The Android
okay. I mean, wait 1 second. I give you the example of Android phone. Android phones are way more complicated than you think it is. It has some basic information that will be always saved inside it, right? You cannot erase that. You cannot erase that. To be operating system, you can change the operating system. You can upgrade it. You can change it. That will be stored in the EEPROM. That will be stored in the EEPROM. The data that is required, that is absolutely essential. You can never change it. That will be stored in the PROM. Like the model number. Can you change the model number of the phone? You cannot.
No, sir.
Like you cannot change the model number or the basic information of your phone. You cannot.
But sir, some people they have changed their IMEI number. But how did they do this?
ওইটা কিভাবে করছে আমি কিভাবে বলবো? কিন্তু normally the IEP তোমার IMEI number, right? IMEI number ওগুলো normally normally OS সাথে তোমার হচ্ছে EEPROM এ থাকে. And like your, okay, let me give you one example. You have a motherboard, right, in your PC?
Yes, sir.
You have a motherboard in your PC, right? In your PC, in the motherboard, there is something called BIOS. You know BIOS? What is BIOS? The screen come up. The screen come up there when you boot your computer. That is called BIOS. That is not the part of your operating system. Remember, that is not the part of your operating system. That is different. That is the part of your motherboard. That motherboard has a PROM. That PROM stores the function or the program that the BIOS required. Now you can change something in the BIOS. You can change some clock speed, some RAM speed, some preference, something like that. That will be stored in the EEPROM. So motherboard has a PROM and has an EEPROM. The PROM stores the BIOS program. Whenever you start the PC, the program starts. ওকে, তুমি কখনোই কিন্তু তুমি তার ওই বায়োস নষ্ট করতে পারবে না। ইফ ইউ ওয়ান্ট টু চেঞ্জ ইউর বায়োস, the whole motherboard needs to be changed. বুঝতে পারছি?
জি স্যার। এখন স্যার আমার একটা কোশ্চেন আছে স্যার,
বলো।
আমরা কি স্যার আমাদের IMEI নাম্বারটা PROM এ সেট করতে পারি না, যাতে এটা কেউ চেঞ্জ করতে না পারে?
ওকে, the programmable ROM PROM নরমালি তো আমাদের IMEI নাম্বার আমার জানা মতো এটা PROM ই থাকার কথা। ইউ ক্যান নেভার চেঞ্জ দ্যাট। আর ওরা ওটা কিভাবে করছে আই হ্যাভ নো আইডিয়া। এন্ড আমি তোমার কাছে এটা প্রথম শুনলাম যে IMEI নাম্বার চেঞ্জ করে ফেলছে। বুঝতে পারছো? তো আমি এটা দেখবো, দেখা যাক। আর আমার যতটুকু মনে হয় যে IMEI নাম্বারটা তোমার PROM এর মধ্যেই থাকে। ঠিক আছে? ওকে। It is not volatile. That means it do not forgets its data. It always retain its data. সবসময় এর ডাটা নিয়ে আসবে। Used in embedded system where the programming needs no change. Okay, let me give you one more example. It is embedded in. It is used in embedded system. Embedded system means like your car music system, or your like your car memory system, right? You have a car. In your car there is a music system, something like that. Or in your car there is a operating system. In modern cars they have some operating system. Those operating system requires ROM. Okay, because you do not need to change data. Used in calculator. Okay, very important thing. Used in calculator, your calculator has a very good memory inside it. It cannot memorize the whole calculation, but it memorize the logics, or it memorize the functions, the mathematical functions. Okay, if you do the integration, it memorize what will be the result, right? So your memory or your Casio calculator has a ROM inside it. ROM. The ROM can be further classified into three types: PROM, EPROM, and EEPROM. So you already know it. You read it by yourself. I already explained that. Now the RAM. Now this is a single 6GB RAM chip. 6GB RAM chip. This is used in your phone. Your phone has 4GB, 6GB, 12GB, 8GB RAM, right? Something like that. Those are actually single chip RAM. Single chip RAM. Remember, those are actually all single chip RAM. It is also called the read-write memory, or the main memory of the primary memory. The program and the data that CPU requires during execution of a program are stored in this memory. It is volatile memory as the data loses its power when it's turned off. That means whatever the data is inside the RAM, if you turn off your PC or if you turn off your device, it will be gone. RAMs are further classified into two types: SRAM, static random access memory, and DRAM, dynamic random access memory. SRAM or static RAM offers better performance than DRAM, but because DRAM needs to be refreshed periodically when it is in use, while SRAM does not. What is the difference between SRAM and DRAM? SRAM offers better performance, but that means SRAMs are better. DRAM are not better. DRAMs are bad, or I should say not better than SRAM, because DRAM you need to refresh it over the time. You need to refresh, while SRAM do not. Okay, however, SRAM is more expensive and less dense. Less dense means you cannot make 4GB, 6GB, 10GB, something like that. You cannot make that big SRAM. That's why, because they are more less dense. Dense means you cannot fit more SRAM in smaller places. So SRAM sizes are order of magnitude lower than DRAM. That means DRAMs are normally GB. That means 6GB, 2GB, 1GB, something like that. And SRAMs are in mega, 1 mega, 2 mega, 3 mega, 4 mega, 16 mega, something like that, megabyte. SRAM are in megabyte, DRAM are in gigabyte in today's standard. And see this one, see this picture. Here you have 8 chips, right? 1, 2, 3, 4, 5, 6, 7, 8. That's why it is an 8GB RAM, because each chip is 1GB each. 1GB each. Okay, now this is a 6GB chip. This one is made for your mobile phones or tablets, because tablets do not need a very big stick. It needs a very small thing. Okay, now There is a difference between RAM and ROM. We are not going to learn about the difference between RAM and ROM today. Okay, let's see this today. ROM, the read-only memory, or ROM, is also a part of data storage that cannot be easily altered or programmed or reprogrammed. You cannot easily alter it or reprogram it. It stores instructions that are not necessary for rebooting and up to make the computer operate when it is switched off. They are hardware. That means hardware means those are actually permanently fixed. RAM, random access memory, or the RAM, is a form of data storage that can be accessed randomly at any time in any order from any physical location, allowing quick access and manipulation. That means you can easily access that from anywhere, anytime, and any location, and you can easily manipulate that. It stands for read-only memory. It stands for random access memory. You already know it. ROM stores the program required initially boot the computer. It only allows reading. RAM allows the computer to read data quickly to run application. It allows reading and writing. Now, volatility. Remember, ROM is non-volatile. That means it do not forgets. That means its contents are retained even when the device is powered off. RAM is volatile. That means its contents are lost when the power is off. Types. It has 3 types: PROM, EPROM, EEPROM. There are 2 main types of RAM: SRAM and DRAM. Speed. Writing data is slower. Speed. Writing data is faster. Okay. Now, next one is the construction. We will learn about this later. That is the next class. Okay. That's all for today. We will go for the lab now. I'm stop sharing and I'm stopping the recording.